This is the LessonCast for section or chapter 5.1.3. How quickly can I sketch it? You already know a lot about quadratic functions, and you've made several connections between the different representations on the quadratic web. Today, you're going to develop a method for quickly sketch a parabola from its equation without a table. So we're practicing going from the equation to the graph today. What do you need to sketch a parabola? How many points do you need in order to sketch a parabola? 1, 10, 50? Think about this as you answer the questions below. Note, a sketch does not need to be exact. The parabola merely needs to be reasonably placed with important points clearly labeled. Can you make a quick sketch of a parabola if you only know the y-intercept? For example, if the y-intercept of a parabola is at 0, negative 15, can you sketch it? So if I'm here at 0, negative 15, is that enough? And I would just have to say, no, that's not enough. Because I have no idea what this parabola is doing. I don't know if that's the vertex or if it's just a point. I don't know if it's opening upwards or downward, but I would have to say a y-intercept alone is not enough information to graph a parabola. B, what about two x-intercepts of the parabola? If you know where the x-intercepts are, can you sketch a parabola? For example, if the x-intercepts are at negative 3 and 5, can you predict the path of the parabola? Or negative 3, 0, and 5, 0. Let's see. So if I have these points, negative 3, 0, and I have the point 5, 0, is that enough to come up with the graph of this parabola? I think that's certainly better than before, but I really have no idea what this parabola is doing. This parabola could come in here and be very, very, it could be very wide and do this sort of thing, but it could open upwards like this. It could open downwards. It could be very narrow too. I have no idea what this parabola is doing. So what I have to say, no, two x-intercepts, not enough information to say what the parabola is. Let's move on. So both of these are no. Can you make a quick sketch of a parabola with only its two x-intercepts and y-intercepts? To test this idea, sketch the graph of the parabola for the quadratic equation y equals x squared minus 2x minus 15, which has x-intercepts at negative 3, 0, and 5, 0, and a y-intercept at 0, negative 15. Where is the line of symmetry? So this one is basically putting the two together. It's saying, what if you have the information from A and B? Is that enough? So let's consider that. So my x-intercepts were at 0, negative 3, and I had a y-intercept at 5, 0, and then way down here, 0, negative 15 is my y-intercept. So is that enough information to produce the graph? I would have to say this is certainly better. One of the things that I know now is this is opening upwards. And so it'll have a minimum value, a lowest point that it'll reach. Also, because I have the two x-intercepts, I could figure out what the axis of symmetry is. So if I'm looking at this, from negative 3 to 5 is 8 units apart. So if I come back 1, 2, 3, 4 units, this line right here, this is the line x equals 1. It doesn't have a slope. The slope of this is undefined. So the slope of that's undefined, but I have but x is always equal to 1. So this line, x equals positive 1, is my axis of symmetry. And because this is my axis of symmetry, I know this, this point right here would have to be on here because when things are symmetrical, right, this is just a reflection across this line. So this point is reflected across that line, and they're going to be equidistant from the axis of symmetry. The other thing that I know is I know because this is my axis of symmetry, x is 1, it's the line in between, it's exactly in between my two x-intercepts. I could calculate the minimum value of this function. And to do that, I do need to know what the rule is, but they told me the rule is x squared minus 2x minus 15. So this rule is y equals x squared minus 2x minus 15. And in order to figure out what y is for this minimum point, I'm going to very simply take the x value that I have, and I'm going to plug it into this function. So y at my minimum will equal 1 squared plus, well, actually it's negative, minus 2 times 1 minus 15. 1 squared is 1 minus 2 minus 15. This number ends up being negative 16. So at negative 16, this function reaches its minimum value. Okay, so yeah, I don't think that I could claim I could draw this curve perfectly, but I certainly have a pretty good idea of what it's doing, right? It's reaching its minimum value here, and it's coming along, and it's hitting this x-intercept and continuing. Same thing on this side, except reflected across this axis of symmetry. So I would have to say for this question C, can you make a sketch of the parabola with only its x and y intercepts? Yeah, I think I can. The line of symmetry for this was the point x equals 1, and I was able to use that and the equation to find the vertex. The vertex of this was, of course, x is 1, and when I plugged 1 into that equation, I got that y had to be negative 16. So with the information I'm given, I could figure out the axis of symmetry. It's going to be in between. It's going to be the point exactly in between my intercepts. And I was also able to find out the y value at that axis of symmetry. Let's see, in the previous problem, you learned that if you can determine the intercepts of a parabola from an equation, then you can make a quick sketch of the graph without a table. A, what is true about the value of y? What is y for all x-intercepts? Okay, what's true for y? So if I'm thinking about this, here's my y-axis and here's my x-axis. It says, what is true for the value of y for all x-intercepts? Well, let's look at some x-intercepts, right? This is clearly not a parabola, but all of these points right here are where this funky function that I've drawn is crossing the x-axis. And I would have to say for every single one of those, the one thing they have in common is x's are all different, right? You can see x is some positive number, x is 0, negative, more negative, more negative. But in every single case, y has to be 0. So what is true about the value of y for all x-intercepts? I would say always y is equal to the number 0. If x is 0 at the y-intercept, okay, let's see. If x is 0 at the y-intercept, okay, so if these things right here, if these x's are 0 at the y-intercept, what is the y-intercept of this graph? Well, if x is 0, both of these parts, right, this part becomes 0 and this part becomes 0 because I'm multiplying by 0, and I get that y is equal to negative 12. Okay. C. Since the x-intercept occurs when y is 0. Yeah, that's true. That's information we just did in part A, right? The x-intercepts will occur whenever y is the number 0. Write the equation that you would need to solve to determine the x-intercepts for this particular equation. Well, if y's have to be 0, this has to be 0. So the equation would be y equals 2x squared plus 5x minus 12. So I would need to know what x's were. Excuse me though. Hello? Y's are going to be 0. So I need to be able to solve this equation for x. If I could figure out what x's were, I would know what my x-intercepts are. The zeros, this is some vocabulary, the zeros or roots of a quadratic expression are the values of x that make the quadratic expression equal to 0. Okay, so that's what I'm looking for. I'm looking for values of x that make y equal to 0. So if I can figure out these x's, at this point, do you know how to algebraically solve 2x squared plus 5x minus 12 equals 0 for x? Explain why or why not. Well, I do. And to be honest, you've been practicing the one requisite skill that you need to do that. So you might say no, or you might say yes here. I'm going to show you how to do that. But this answer is whatever just honest answer truthfully. You either know how to solve this equation or you don't. Let's go to question 27. The zero product property. The equation that we just wrote in part C of problem 26 is called a quadratic equation. To solve it, you need to examine what you know about 0. Study the special properties of 0 below. Nathan, Sonia, and Gaston are playing a game where Nathan and Sonia each think of a number and then give Gaston a clue about their numbers. Using the clue, Gaston must tell them everything he knows about their numbers. Nathan and Sonia's first clue for Gaston is that when you multiply their numbers together, the result is 0. So both of these people, right? Nathan has some number and Sonia has some number. And when you take the numbers you have and you multiply them, and I don't know what they are, right? They're mystery numbers, but when you multiply them, you get an answer of 0. What conclusion can Gaston make? Well, this was a homework problem, I think 2 nights ago or 1 night ago, right? What are the special properties of 0? Turns out whenever you multiply something by 0, you get 0. And in fact, the only way that you can get a product of 0 is if one of the things you're multiplying is equal to 0. So I think that Gaston would have to say one of the numbers is 0. Let's see. What conclusion can Gaston make? Maybe he said both were 0. I don't know. Disappointed that Gaston came so close to figuring out their numbers, Nathan and Sonia invited Nadia over to make things harder. Nathan and Sonia and Nadia all think of secret numbers. This time, Gaston is told that whenever the 3 secret numbers are multiplied together, the answer is 0. What can Gaston conclude this time? I think one of those numbers has to be 0 still. You can't get a product of 0 unless one of the numbers is 0. Does it matter how many numbers are multiplied? If the product is 0, what do you know about one of the numbers? This product is called the zero product property. With the class, write a description of this property in your learning log. Title this entry zero product property and include today's date. So I don't know, I've written whenever you multiply 2 or more numbers and get a product of 0, one of the numbers must be 0. It does not matter which number is 0, and I don't want to say the product will be 0. It doesn't matter. The product's obviously 0. It doesn't matter which one of them is 0, but one of them must be. And actually, maybe I should say, but at least one of them must be, because you could have several zeros, right? But one of them must be. Okay, let's move to question 27. I'm sorry, 28. Let's investigate how you can use the zero product property to help you solve the quadratic equation 2x plus 5x minus 12 equals 0 from part D of problem 26. Examine the quadratic equation. How can you write the quadratic equation as a product equal to 0, things being multiplied together, giving you an answer of 0? Well, that's one thing that you guys as a class do extremely well. You're able to factor quadratics with little or no problem. So I would say, hey, let's go ahead and factor that thing. It says, examine the quadratic. How can you write it as a product equal to 0? Okay, I'm going to say using factoring. Now that the equation is written as a product, oh, okay, well, I haven't done that yet. Let me go ahead and factor it. So I've got 2x squared plus 5x minus 12. And I'm going to use my generic area model. So this is 2x squared. This is a negative 12. When I multiply 2x squared and negative 12, I get negative 24x squared. And I have to find two numbers that have that product, but they have to equal 5x's. So, okay, 5x's with 24. 24 is the number, well, it's 2 times 12, and 12 is 2 times 6, and 6 is 2 times 3. So I'm looking at 1 times 2 times 2 times 2 times 3. Oh, I think I've got this. Maybe 2 is an 8, and 8 times 3 is indeed 24. So I think because I need a positive 5, I'm going to go with a positive 8x and then minus 3x. If I add those together, 8 and negative 3, I get 5x's. And when I multiply, I get 24x. So my two values here are 8x and negative 3x. So what I'm going to do now is, if I look at this, the common factor of these first two terms is just an x. And then I always, here, let me pull this down and move this down a little bit. Oops. The common factor of these two is 2x. And I always do those two in that order first. So I brought out an x and I brought out a 2x. Now, what do I multiply x by in order to get, or 2x by, what do I multiply this by in order to get 8x? Well, that's easy. I'm going to multiply that by 4. And then my last question is, what do I multiply 4 by in order to get negative 12? That would have to be negative 3. At this point, you can see all of the pieces work, right? If I multiply negative 3 and x, I do get negative 3x. And if I multiply negative 3 and positive 4, I do get negative 12. And when I multiply 2x times 4, I do get 8x. And finally, when I multiply 2x times x, I do get 2x squared. So I know what my factored form is, right? My answer should be x plus 4 times 2x minus 3. And the equation, remember, it equals 0. So what I've just done is I've transformed this equation into an equation where I'm multiplying things together and getting this product of 0. Now that the equation is written as a product of factors equaling 0, how can you use the zero product property to solve it? Since you know that one of the factors must be 0, you can set up two simpler equations to help you solve for x. Use one factor at a time and determine what the value of x must be. Well, this is sweet because I know one of these has to be 0. So I would start with this. I'd say x plus 4 equals 0 is one of the simpler equations. And the other one would be 2x minus 3 equals 0. That's the other simpler equation. If I solve this first one, I can, by subtracting 4 from both sides, I see x is negative 4. And then if I solve the other one, I'm going to add 3 to both sides. That gives me that 2x equals positive 3. And then when I divide by 2, I get that x is equal to 3/2. So I can see right now what my x-intercepts are. It says, what do these solutions represent? What do they tell you? Well, these are x-intercepts, or you could call them zeros, or we could call them roots. But they basically are telling me where this parabola is crossing the x-axis. You now know the zeros, roots of 2x squared plus 5x minus 12. Use the zeros to determine the x-intercepts of the graph of y equals 2x squared plus 5x minus 12. Then determine the y-intercept and make a quick sketch of the parabola using the x and the y-intercepts. So I've kind of set up a quick graph space here, and I know that my x-intercepts are at -4, 0, and the other one is at -3/2, 0. And I know that my y-intercept happens when x is 0. So if I plug x as 0, oh, this is 2x squared. When I plug x is equal to 0 into this equation, I get that y has to be -12. So I'm thinking, you know what? It's great that I've got the graph paper here, but I don't want to use that. I just want to do a quick sketch. So, oh, this is +3/2. So just real quickly, I'm looking at about +3/2 is like 1.5, and then at -4, it's 1, 2, 3, 4. This is -4, 3/2, and my y-intercept is way down here at -12. I'm going to just I don't know that this is -12, but I'm just going to roughly sketch that. Now, when I look at this, my axis of symmetry is a little concerning to me. It's the distance. This number is 1.5, and the distance between -4 and 1.5 is 5.5. If I take half of that number, half of 5 is 2.5, and half of 0.5 is 0.25. So I think I've got like 2 3/4, 2.75 negative. So -1, 2. Actually, so this is not the coordinate of the axis of symmetry, right? This is how far I travel from -4 or from -3/2. So if I'm right here at -4 and I've got to travel 2 3/4, this is 1/4, 2/4. No, I mean that's 1, 2, and then right here is a half, and there's 3/4. So this number right here, which is -1 1/4, that's my axis of symmetry. So, and it's happening when x equals -1.25. So this is the x value for my axis of symmetry. So if I'm just producing a crude sketch here, right, I would say it's something like this, right? It's definitely opening upwards. It's coming down here. It's hitting this point, and it's coming up here. What I don't really know, because I don't know the exact vertex, I don't know exactly what's happening. Whoops, let me zoom out a little bit. I don't know exactly what's happening down here, but we could figure that out by plugging in the -1 1/4 and finding exactly what y is. So question 29, it says, can you make a quick sketch of a parabola from the two x-intercepts and the vertex? And yeah, I think I could do that. I think I could do that. So where are the x-intercepts of this parabola? This one right here. So for this question, guys, I'm gonna have you work through this one on your own. I think I think you could probably figure this out if you're talking to your groups. What is the vertex of this parabola? That's a good question, right? We need to know the vertex is two things. It's the x, that's the axis of symmetry, and then it's the y value that you get when you plug the x in to the equation. So you could get the x and the y. And remember, this x for the axis of symmetry is the point that's the midpoint between the two x-intercepts. and then it says sketch the parabola. And in this problem, use the x-intercept and the vertex to make a quick sketch. In the previous problem, use the x-intercepts and the y-intercepts to sketch. Which was easier for you and why? Well, I haven't done both, but I would say I probably prefer this one more because I know what the bottom is. Although it's probably more difficult to calculate this point, I think I'd feel like it would be more accurate because I would know what the lowest value of my parabola was. So there's one more box here, methods and meaning, and they have here an official write-up for the zero product property. When the product of two or more numbers is zeros, one of those numbers must be zero. This is known as the zero product property. If two numbers are represented by a and b, this property can be written as the following. If a and b are two numbers where a times b equals 0, then a is 0 or b is 0. For example, if I have the factored form, actually that is the factored form of a quadratic, 2x minus 3 times x plus 5 equals 0, then either 2x minus 3 is 0 or x plus 5 is 0. And if I solve for both of those, I get that x is either 3 halves or x is negative 5. This property helps you solve quadratics equations when the equations can be written as a product of factors.